So that means it's got a bigger screen. There's some basic function keys here, but pretty much everything is just
touch.
under this big.
The only thing you guys are gonna use the system key twice a year. Let's go in here and change time. Set daytime.
Or just let the 3 weeks eclipse.
Yeah, exactly. But
Or be wrong 6 months a year.
yeah, that's the. And then we have the operator. So this is what main menu.
Right, pretty simple.
And this is basically, I'll take it, you can go to this screen and navigate to your others.
We changed.
We'll just step through them one by one. Operator screen.
Yeah, like in 2000.
This is what your operator is going to primarily operate the machine off of once the settings are set up. So you've got modes, hand, auto. Which test would you like to run? A burst test only, a static test only, or both? When both is selected, it's going to do a static and then a burst. I don't think it would do much good to do the burst and the static if you blow a part up.
Right, exactly.
And then the function, you've got a start, a stop, and a pause. Here we're displaying the actual pressure in the system, and then the displacement in cc's. Here you can change your part numbers, and this is 32-bit, so you can have a whole bunch.
Right.
And trial number. And the reason why you'd want that is for data logging.
Yep.
You can keep track of what's what.
Carl had mentioned that before, that if we do that, then the reporting out of it would make a heck of a lot more sense. We can view trends and whatever.
So yeah, it's going to give you data.
This. You go 1, 2, and so on, and then that's the same part numbers, right? And then you just at the end of the day you throw them away or whatever, and then somebody says, "Oh, hey, what happened? 23." I was okay. 23.
Water temp, it's showing the actual water temperature and the cabinet temperature. Reset, will reset major alarms. We open that. It's going to say cabinet door open, but this is part of the safety relay. And so it's reset the cabinet door, but the relay is not set or reset, so it says e-stop. So we hit reset. Clears the function. Navigation takes us back to the main screen again. You've got a trend screen. While we're running, you can watch the PSI and your displacement graph. That's the trend screen. Navigation again. Burst parameters. So in here's where we can set all the parameters for your burst test. Target pressure, it's going to go up to 800 psi in 6 seconds. And again, you can go the largest number I think I've got you allowed to set. Yes.
Is 1,000.
1,000. Enter. Yep. Oops. 800. Enter. So the number of seconds to get there, you can go 0 to 1,000 seconds. Flush time, it's going to open the inlet and the outlet valve to flush any air out. For this, between 5 to 120 seconds. The hold time, well, on a burst test, you're probably not going to hold it.
Right.
We've got 1 second. Go up to 800 and then come right back down.
Right.
But I tried to emulate this. I did a static test first, and if you decided, it's almost identical to a static test.
Okay.
The pass pressure, we're going up to 800 psi, but once you get to this pressure, it exceeds that, it's going to pass the part.
Okay.
And you can adjust that 0 to 1,000. Water temperature limits.
Just alarms?
It's going to cycle. If you fall out of temperature right now, it's going to cycle stop it.
Okay.
It's going to abort the test. And you get a low limit and a high limit. I personally opened them up so I could run my testing. And then the cabinet alarm temp, same for that. And these they're the same registers, the same set points from the static to the burst. So my point is, I think they are. If you change them here, they're going to be changed. That's not true. Never mind, forget I said that. They're different registers. Displacement, if we ever exceed this amount, it's going to fail. No, you have a bad part. And I've got it set at 20 cc's now, and you go 0 to full stroke is 240 cc's.
Okay.
So if you throw, let's say you're going to a brand new part, you've never seen it before, well, what should I set that at?
Open it up.
Well, you could set it up high, and, you know, if you're gonna fail a part, it could open up and leak, and then pour all kinds of water out, and at some point, that ram will hit and bottom out, your test is over, and you'll have burned up like 240 cc's of water. That's what this thing can do.
Okay,
Well, but if you did if you brought it up to, pick your pressure, 400 psi, 375, and you'll see, oh, it's only 13 cc's that it's displaced. Like 13 is pretty much what all those parts are going to do. At that same temperature, they'll all be about, you know, you bleed out the water or the air. Anyway, so you'll wonder, what should I set this machine to? Well, something bigger than 13. And if you want to catch small changes, maybe 13.5 or maybe 14 cc's. That way, a small little change, you'll catch that. The first 13 we're kind of ignoring, and that last little bit, then we're going to catch it. Or you can just say, well, look, I don't really care. 20, 30, 40, 50, put the number in. And if it leaks, it'll eventually leak to that amount. So what you're doing is you're actually telling the machine, when should I call this?
right.
Yeah.
What's my criteria? 20 cc's?
And you aren't going to know that until you
Run it
probably get your
Absolutely.
few in there, open the parameters up so it doesn't fail, and see what that displacement is, and
Correct.
you'll know, here's our target, plus, or shouldn't say minus, plus X amount.
So right now 20 seems to go pretty good for your parts here.
Yeah, well this morning we had to open it up because I didn't bleed all the air. I think they're running
Spongy
about
brakes.
8.8 cc's right now.
Okay.
And I'm set at 20. I was set at 12. It's like fail. It's like, what? When I was here last week, Thursday, we weren't failing, but we took it all apart and I had too much, I didn't flush it long enough.
Okay,
And then once I ran a few parts and flushed it, then we came right back down. What did we have? Burst. Here, let's go into this one, the static pressure. So it's almost identical, except we do not have this one here. And that was once you exceeded X PSI, we're gonna pass it, even if later on it fails.
Yeah, you guys said we have to clear 500,
right.
but bring her up to 1,000. So there's two numbers, the 500 and the 1,000.
But you can adjust them.
In static, you don't have the 500 number.
Yeah, it's like we're gonna go target pressure 375. I want you to get there in 4 seconds. We're gonna flush it for 8 before we start, and I want you to hold for 30 seconds. But you can go 999 minutes and 59 seconds and just hold it there.
Right. And all these parameters are going to be determined by,
electrolytes.
correct.
Yeah, I think it was going to be a 15-minute, 375 by 4 seconds by 15 minutes, 0 seconds. And flush
I
it.
didn't want to set
Flush
that-
for a while. Flush for 10, 15, 30 seconds. Just get all that air out of there.
Right.
And then again, you've got the cabinet temperatures as well. So this is static is almost identical to the burst.
Keep in mind this weird thing though, if you got well water and it's cold at 52 degrees and your room is at 85 degrees and your parts are at 85 and everything's at 85 and you were gonna run 52 degree water through them, you've just changed the game.
Yeah.
So the more you control all the temperatures and you keep it that way, all your data will be the same.
Yeah, that's what we want to do.
And besides, it will be warmer. Even though it's air conditioned, that doesn't mean it's going to be
75 for them is freezing.
correct.
Well, you need to keep this at 75 or less if you want to try to comply with an NSF test.
Yeah,
Okay.
well, it's going to be probably right at 70 is what it'll be set at. And most people will be wearing a parka to go in there and do it. Where do they live?
Monterey, Mexico.
Oh,
that's
Mex-
why, okay.
Corey was down there last week. It was 80 degrees. He said everybody in the plant had sweatshirts and jackets on.
Different people.
And he's wearing a polo shirt and they're shaking their
So they
head
wouldn't do well up
Gringo.
here.
Loco.
They don't like it.
I didn't like it this morning.
I didn't either.
-2.
IO status, that
Yep.
stands for inputs
Input,
and
outputs.
outputs. Hey, yeah, boy. So. And then input, I don't know what they all are. 1 and 2, so 1 is the door, 2 is the safety relay. What's 7 and 8? And here we can kind of see our A to D is coming in, analog digital conversion from our, that's a raw number. It's usually 0 to 32,000.
Okay.
So everybody says it's 4 to 20 milliamps. Well, the PLCs don't read that. You get a number.
Red lamp is 7 and 8 is yellow lamp.
Why was yellow going on?
Those are outputs, right?
I don't see yellow.
Well, I got
Maybe we just found a
6, 7, and 8 is green, red, yellow.
maybe your programmer made a mistake. I'll look at that in a bit.
Corey, where are you from? Cannon Falls?
No, LeSueur.
LeSueur.
Beautiful town.
He stops on LeSueur or Leeseur.
Yes. I don't know.
Depends where you're from and how you like to
But
pronounce
La
it.
would be
Sort of.
feminine and Lee would be masculine.
The gentleman that same with Le Center, no, Lee Center.
Yeah.
It's always Le Center.
Yeah.
I've
And
got.
always
That's where
LeSueur.
our shop is in
Le Center.
Le Center. Lee Center. Yeah.
Well, it's a weird word in the law. I bet it's French, so I bet
It
law.
is
I bet
French.
it's law then.
Yeah, I'll look at that. I/O screen pressure calibration. So what we did is calibrated this. We have our analog to digital conversion. We took this down to 0, and we were setting at about a negative 44.
So
by
just
opening the
interrupt.
whole system
So what
up.
happens is we're giving it an analog voltage. So like 0 volts is 0 pressure. So what is 0? I mean, really, what is 0? So when this voltage goes into that PLC tries to convert it to a digital number. And I think Corey's working between 0 and 32,000. So we're going to cut 10 volts into 32,000 pieces. And so what you're doing is you're saying, you know what 0 is? See, right now we're dithering at 11, 12. So digitally, it's trying to say, we're right there. That's what I'm reading. You want to call that 0 PSI? Be my guest. Now you've just said that digital input is now 0 PSI. Then you bring it up to pressure, and again, you'll see this number is now like 23,000 or something. And you go, 23. You'll enter that number in here, and then enter. And so you've actually locked 0 and span.
In whatever pressure you were at.
Clear as mud.
Clear as mud,
It may be a phone call first time you want to mess with it.
I would guess. How often will we have to mess with it?
Shouldn't have.
Shouldn't.
Right.
This
Once
pressure
we're set up.
transducer can handle shock and much higher pressures. It's never going to see that.
Right.
So it should go and go and go.
Perfect.
But, I would like to say that it'll last that way forever, but I think as a practical matter, somebody from your quality department needs to do a systematic check and see that the standards are being met.
Correct.
So that's probably when that gauge comes out, and then you do a 0 and span and see that it's right.
Okay.
I don't know if it's once a week or once every 6 months or something.
Now our folks down in Monterey tend to go overkill. And so my guess is they'll be doing it once a week.
Do you mind if I look at it? You still.
No, you're doing good.
So
next
yeah, so
box
we
is
did the
the
same
same
thing with the stroke calibration. We took it back to 0 and then
Yep.
extended it fully. So 0, or A to D at 0 was 70. So you got 0 A to D and 0 actual. So at 0 we were reading 70. So I entered 0 in there for the actual CCs, 70. And at full stroke, Carl did the math, 243.CCCs equals 32,079.
Okay.
Yeah, so a 3/4 rod displacing 10 inches, so many cubic inches, that's how many cc's.
Got it.
And so that's basically, pretty much think of it as you got a 3/4 inch rod going up inside of a volume, and so you're displacing that rod metal
The
with
volume of
water.
the rod itself.
Yep. So that's a 243 cc machine. And we're breaking that down into micro inches. So how many micro inches is equal to 1 cc? So when this thing says you've got 10 cc's, that's because this thing moved up some small amount.
Right.
And it's repeatable.
What's that though?
I was wondering if the light can only do one color at a time.
No, I know what the problem is. I'll download it and fix it in a minute. I had the address on light 8 the same as light 7.
Ah. So you
And
never
that's
had
why
it
they
on.
were going off?
Yeah. Programmers, terrible.
God, kids nowadays.
Exactly. Same for the temperature calibration. Hey, no, they're right.
They're right when they switch modes. I think it's a plus 30.
It's
I
not
don't think
because
it's a
I'm
voltage.
looking at this number.
I don't know what it is.
I don't know. So we did the same thing here. This isn't as easy to calibrate. Well, we had to pull them out and go into
Yeah,
a
we stuck them in an ice water and then like
Hot
170
water.
Fahrenheit.
Yeah, it was
so we
171.
zero and span them at those two.
And you shouldn't have to touch them.
Okay,
And just for the record, if this were to die, I've gone and uploaded all of our parameters that we've entered in there, including the calibrations. So if this were to die,
Can
we
put a new
program
one in.
another one and shove whatever it leaves here with is you'll have a starting point.
Yeah, if you find
like
there's some
I
minor
have.
program mods that may need to be done, no problem, we'll just get on it. And so if you want to flash a new piece of code in it, you know, we work on the computer, create the code, burn it to a little thumb drive, and then you can insert that thumb drive. Can you do it off USB? If not, you have those little
There's
micro
a
SD
micro
cards.
SD card too.
Mhm.
It goes in the PLC, and then you use the system menu, a couple things, and it's actually
On
very
the
quick.
removable media, it's
We'll
not
show you
gonna-
that before we're done.
There's no
how you can
card
change
in
it.
there, but it's like,
so if there
oh,
was, we could pull off of it.
yeah, you'd see it here and enter it, and it would take the program and update it for you.
Cool.
I love these screens.
Mhm.
Then you have the manual screen.
Yeah, Manuel's what they
That'll
say.
work, that'll work for down south.
Turn on the yellow light.
Oh, he has to upload.
Hold
the
on
code
though,
first.
let's reset that. Yellow light.
Oh,
Oh, we got the
That's-
green on, so green's on right now. But it's on because we're in auto. Anyway, cabinet, fan. Yellow, we can see it's on. Green is already on. Inlet valve. Outlet valve.
it's the pressure gauge
There's the
That's a
pressure.
high flow valve thing.
Red, yay. We can
on it. Just
close, extend the pump. How many PSI you wanna go up to? Let's go up to 100. Oh, magic.
Mm-hmm.
500.
Almost like you told it to do that.
No, this is,
Wanna go to
this is
1,000? No,
unguided
I don't wanna
manual.
break the
I was gonna say, can I borrow it from my wife? I shouldn't say that. She's actually pretty good.
So it's pretty spot on. Did Terry always say that? 0. Then you can retract the pump. Open the inlet, open outlet. I think I already did that.
You're gonna
Just
find
a
at some
way
point
to-
the displacement won't read 0.
What is this? Did I can't afford?
You did, but if you have nothing driving
Well,
it, 0 is kind of like, whatever,
gonna
like
fix
you were
that
just
one
gonna
problem.
kind of set your calipers. But if you actually had your city water pressure, what you have tied into, and the valve's open, now it's being pushed down like your thumb, not really pushing for 0. So there's gonna be a small difference. So when you calibrate this thing,
I'm
when it's
downloading
really
that to
being
get your
jammed
little
out.
light to flash, right?
And it'll be 0 at the start of your test.
But it's pretty cool little machine.
It is a cool little
Should we,
machine.
we'll probably go back to this, but dare we run apart?
Heck yeah.
Yeah, I think so.
So you, what have you done with this
Obviously
one?
go to 800.
Yeah.
Yeah, we
I've
did.
taken
Well,
them to
let's-
1,000. I've accidentally taken them about 12, 1300 too. It's like, whoa, boom. Like,
Let's
huh?
go ahead and prep apart then. So, it turns out that
There,
your
much
tubing
better.
is part of the system.
I had this.
Yeah.
You can't directly, because of the type of button it is, it uses a register value, a word, and you address bit 1 in it. You can't.
Oops, sorry.
You can't do it to the output. I want to copy 227, 228, 229, 227, 228, 228.
So you take a manifold,
Yeah.
That doesn't make sense.
you'll establish what length that you want.
But
So you'll
otherwise,
set up a jig,
I like
you'll
the
come to
looks
a
of
length and cut it. And the reason that I would do it this way is that the tubing is gonna flex.
but it won't let you just.
Yeah.
And that means how many cc's. Cold tubing that's short, no flex. Long tubing that is hot, flex a lot. So that could change your test results. So then take this tube and insert it into here and then push it in the whole way. Gosh, I can't the tube. Well, we'll see what happens. But there's how you prep one. And then that goes in, quarter turn, tell a click, and now you're in.
set up the alarm. We're gonna do both tests. Start. Probably, we'll see if we flush this long enough. We might fail. Oh. Look at our displacement.
Slow yellow light is your static test.
Okay.
What was the timer set for on the static test?
You're right
just
here.
now?
You're holding right now. And
Okay, it's counting down. Got it.
Congratulations, Evan.
Here's the burst. You could try it. Oh yeah,
This one is
scary.
like, you wanna watch it, it's gonna happen. So you
made
should
it.
run that to 1,000, because that's what the test is gonna mean.
It survived up to 800, 'cause that's where it went to, right?
Yeah, 800. What do you want to know?
He said
1,000.
Well, they don't.
They haven't really said.
Oh, we can
You're
go.
saying-
It's like 500.
Your email said clear 5, drive it to 1.
Right.
You want to drive it to 1?
Sure.
But you know, I think that was a guess by us for the 1,000.
Do it? I mean, that's what full throttle's for. So, if you hadn't said this already, this thing has really 3 modes. Static, burst, and static burst. And so your test is to do both those.
No, we're in the static again.
Oh,
We could set it up for
30
burst.
seconds.
That's okay, we'll let it go.
It's only 25 seconds.
That's why I didn't have that set for 15 minutes. Otherwise, I'd have got nothing accomplished for months.
Got it.
Look at that, 375. That was fun.
It's 374. What do you?
Hold
you
on,
look-
hold
you
on.
looked at it and then.
Come back down one. That was fun trying to hold it perfect. Now it should go up to all one.
It's flushing right now.
And if you decide you don't want to flush for the second test, you just go back in the parameters of burst and say flush at 0.
Yeah, it's all gone.
Just like that. Hit 1,000.
So now if you want to break apart, we can break apart.
You just take pressure further.
Let's go.
Thousands of max.
Why don't you set up, Tim, you try setting up the static for 1,000 pounds.
Static.
Yep, set up the static test
So I
at
gotta
1,000
go.
pounds.
I gotta go to navigate to go
Yep,
back.
go to navigation.
And
Static parameter entry.
Bottom, there you go.
all right, what do we want to set it to?
1,000. Let's
Okay.
break something. And then run it there for,
So
I
then
don't know,
hit
5 minutes.
navigation.
Oh,
Operator
you're only
screen.
static though for.
30 seconds.
Try
Yeah.
it, see what happens. Now just start.
Well, you're on both right now.
Are you? Yeah, you can.
Just click static
Right.
Oh, over here.
on the test.
Yep, start.
Well, we'll run the static first, right?
I was gonna run 1,000 and then
And then it's
1,000.
correct.
We can make that a little bigger.
Fat finger guys. Yeah.
Well, I mean,
Yeah, a little bigger in mine.
so now you've got it up to
The
1,000
kids'
pounds,
sausage fingers.
and it's gonna sit there, and what'll probably happen is you'll rupture the tube where I creased it. And then as
Will
it
you see it?
ruptures, you wipe the tube.
There you go.
There it goes.
So there's some stress in that,
Oddly, didn't it blow down the bottom though?
see, there's some stress
Yeah.
there,
Oh, okay.
so it failed.
Static test failure. Of course, I can't pick that up on my phone. There I can.
Okay.
Now you're acknowledged.
Okay.
But
I'm
we want to
so-
pop that up there.
somebody.
We
But
want
now you did that test. The next part that we put
You're
in,
done.
we go back in here though and change these
Yeah.
two output or these inputs to 2,
Yes,
right?
correct.
Got it.
I would like to see this.
So,
It's the same.
probably, normally speaking, nothing's gonna happen to your parts. These parts are too good for
This
this
is that
test.
guy.
Yep,
But if you're gonna check this
Here's your
repeatedly,
rupture.
then don't kink the tubing, like I did.
But that didn't seem to matter though.
I found that if you hold them at 1,000, it's gonna go eventually.
but when these tubes are slightly warmer, they may not kink as easy either, Carl. Although you're 70 degrees in here, very close.
60.
68, well, according to the cabinet.
It only travels about half an inch, right? When you insert
It's
it.
getting harder and harder for me to push. Yeah, I probably had it in
That's
right
called
away.
older age, Carl.
Turn that camera off.
Sorry, Carl. Now, do we change?
I should have put a
Do you
trial
wanna
number on
try
it.
and break another one, or?
So, hang on. This is trial number 6, just so that we know. 6. And then I want you to put down what trial number this is. There's a reason for it. Wait, stop.
Part number 1, trial number 6.
See, if these are, part numbers 1, 2, 3, 4, 5, 6, 7, they're all that part number.
Got it.
Unless
Like
you're
you
gonna run
like your subs.
different, but,
Does now though.
Yeah, now hit start.
so you're actually,
Oh,
we're gonna
reset.
do data logging.
It's on.
Reset.
Okay, so we're gonna actually look for trial number 6 now and see what
I
happened.
hope it works.
This is ramping to 1,000 psi and then holding.
And we're up to 1,000. And it's holding.
Carl never sent this tube.
Test
so it may-
failed.
It failed. I don't see a break.
Might not have broke, but I bet we did our displacement.
Did we flush it enough?
Probably not.
Flush her longer and then, try it again.
So navigate.
I think 10-second flush is for the impatient.
Oh,
I think
yeah.
it should be, closer to 30 seconds.
You want 20 or what do you want?
I'm still impatient.
Here I am running it, sorry.
That's okay.
That's alright.
I do that at work and people yell at me all the time. You want to teach us something, yell at us, talk to you guys.
Well, there is something they said that doing, you remember.
So
you
we
can't
adjusted the
more
flush
than
time on this from 8 seconds to
I
20
agree.
seconds.
I have very aerated water here too.
Intentional.
Alright.
Our
And
displays.
we're ramping up, 1,000.
1,000. 1,000. We're displaced about 16 and a half feet.
16.4, 16.5, 16.6, 7,
Yeah.
16.8, 9, 17, it's creeping. Something's changing, 17.5.
And blew out the
Blow up
bottom
the
again.
tube
So
again.
what we were probably measuring was the beginning of an aneurysm. And
So we're starting the tube must be.
so this machine has the ability to do another thing that it has not been programmed to do. If you guys wanna do it, it'll be another sub-project. But we can actually data log, like high-speed camera, watching those things. So you can plot the graphs of this event.
Okay.
If you wanted to diagnose properties of this plastic versus that plastic. Right now, this is like a production burst tester, just give you the numbers, boom, boom, boom. So there it is.
Not to mention, like you said, realistically, it's like an apple that's going against a tube or something.
Yeah.
So if we started having manifold failures.
Right, let's say this was filters you were building, and
Yeah.
you were building freeze-resistant filters. That's really what the whole idea of this machine was about, was to watch the canister stretch. And so you could see the way, what kind of failure, was it a brittle failure or a ductile failure?
Yeah.
That's what this machine will show you. Right now, we're not doing, we're not doing that really. So the data logging that is being done is actually being written.
Yeah, we failed the one.
Corey, where,
Yeah.
oh, you took it out already? Good looking at it. So, sorry.
The data, you mean?
Yep.
So
So
these
it
are
is-
both-
took the USB stick out, plugged it in, and
Click
on the
there, so
USB
it's-
stick,
This?
This little
it's a
line.
CSV file.
Oh, yeah.
CSV.
Comma
But
separated
Excel will
variable.
open that up readily, and it'll look just like Excel.
Okay.
Cool.
So you can see your lab. These are the.
Somebody
We were
bought-
logging data,
somebody bought
but
you
here
a
are
Christmas
your
present.
test test number 6, part number 1.
Excellent.
Yeah, so these are cryptic things that I was writing down, but we can, S means static,
Static.
and B means burst.
Okay.
So if you haven't already, so your part number is 1, part number 1. Let me just take it. And then your trial number, here, look at this, 6.
Right.
Oh, wait, we just did that one. And so then you have your target value. We set the pressures. We were doing 375s. Now we went to 1,000. We did 3 1,000-pound tests. We did it in 4 seconds, which actually is a bit fast. You really shouldn't go faster than a second per 100. So it should have been a 10-second ramp. Shame on us. Then we flushed it. We decided we're going to flush it more aggressively, so we flushed it 20 seconds. And once we get to 1,000 pounds, we went right back down, no hold. And
What are you talking about?
well, no,
This
in
was
minutes.
a
Sorry, this was a static test. The minutes were 0 minutes, 30 seconds. So we ran it 30 seconds. 0 minutes, 30 seconds. And then we said 20 cc's was our trigger. This thing actually recorded a maximum of 24/7. And these were your temperatures in the cabinet and the water. And then this is cryptic here, but static fail is 0 and pass is a 1. So here's a 0. That means it's a fail.
Failure.
And then it did it at 0 minutes, 13 seconds into it.
Cool.
And so it's just going to, every time you run another test, it's going to append another row.
Perfect.
Then we also have my head in the.
No, you're good.
I don't know where your mouse is. Oh, there it is. It's way faster than mine.
Well, when you have 3 monitors, you have to hurt your wrist, you know.
I wouldn't know. I'm a one monitor kind of guy.
Oh, it's very productive to have multiple.
Huh? Oh, I screwed up.
You could open the same file
trying to go?
twice.
Get rid
So
of
there's
that
2
one.
different directories it makes. It's a static directory and a burst
What are you trying to
directory.
do?
So you'd open up
Close
the
that
burst
one, too. I
file,
think it's right there.
and then
This?
they're all
Yeah,
going to
so
be in
they're.
order.
Oh, did I
This
open the
isn't it.
burst?
So.
Oh, I know. They're
So,
the same. Not yeah.
static?
Close that. Close this one. You have to close this one.
Don't save. So these.
No, go to burst.
That's what I opened. I thought.
Yeah,
Maybe I
these
did. No, I
files
did
are,
static.
even though
I
they're in
did
different
static.
directories, they're
Yeah.
exactly the same file number. How do you derive the file numbers?
I don't know. I can look that up.
So what happened here? We have no trial 6.
Yeah, because we didn't.
We
go
didn't
burst
do
test.
it.
We just did static.
Never got
Well,
to
it
the burst.
broke on the static test before it got
Yeah,
to the burst.
Yeah.
So we played around with a bunch of tests. We did, these are B for burst, an 800 pound, 800, well, the last one we did, this one is a 1,000 pound test. So we ramp it in 6 seconds, we're flushing it for 10, we're holding it for 0 minutes, or seconds probably, holding it for 0 seconds. And then we set 20 for the displacement. If we exceed 20, game over. Well, this one, we saw 21.8, and that was 67,
But-
63. But it turns out
Oh, I
it's
see.
a fail.
I see the parameter I'm missing on
We
this right
failed.
now.
But
this
it's
one.
showing it as a pass on one.
It did pass because I'm missing a parameter on here.
Okay.
Remember, we can pass it as long as it got over 500 psi.
Ah, you're right.
That's the parameter I'm missing. It's like I know I'm missing
Yep,
something.
I get it.
I need to throw that on. there.
So, Tim, on the setup screen, when you're doing your burst, you have to clear 500 to pass. But we're gonna try to break your part anyway.
And, well, yeah, that's why we were at 1,000. We were trying to break it.
Yeah.
Right,
Passing-
so even though the data
Passing was
looks
never
like a
really the
failed-
goal. We
even
knew
though-
it was going to pass.
Even though the output here of a 1 of a fail, like Corey
Nope.
said, doesn't matter. Because we achieved the 500 right off
Right.
the bat.
Yep.
Got it. All right, I think that's enough video for now. My arm's starting to get sore. 34 minutes
Yeah.
worth. They'll be tired of watching this.
Yes, they
Sensor's
will.
hot.
So this is what it looks like inside. It's not too magical.
It's just all the blood I put towards this project, all the cuts.
Oh, that manifold.
Wiring's hard.
You know what? We brought out the 4th axis to machine that part. It's kind of neat to watch a thing.
Oh, cool.
Well, that's only the 4th time.
Well, we built the part perfectly. It's just that it was clockwise instead of counterclockwise. We made a mirror
That could be
opposite part.
That could be a problem.
You gotta be kidding. So what happens here is there's your power, 24 volts. It floods this thing. So the bottom one is 0, the top one is 24. So we run everything it needs hot and cold or 0 and 24 into that. We're using the European standard. Brown is hot, blue is not. So if it overheated and smoked, it would turn brown. That's hot. And blue is as safe as the sky.
Okay.
So that's your blue. I don't know why it's European, but all the sensors and everything you buy nowadays, they all run that same thing. So there's your line in. So you're coming in here with 120. Black and white go into here. We convert everything else to 24.
The black gets switched here.
Yeah, we have to run the black here to switch it on and off, and then it goes back. And so anyway, this is a safety relay which watches this magnetic door switch. It's got 3 circuits in there, and then it watches the e-stop, which has got 2 circuits. And these basically are in series, so if 1, 2, 3, or 4, if one of the 4 circuits has an issue,
Off.
it's off. And then this thing, like, it watches it like a hawk, and it'll watch whether the contacts are corroding and whatever. So this is a safety related device, and it bypasses the PLC. So if you hit an e-stop or open up the door, or there's some other kind of failure in these things, off, safe, and it doesn't matter what this guy's doing. So it's a safety circuit. And then these are some relays for some things that require a little bit higher draw, like the cabinet, fan, and
the reset, the relay.
you have to bridge these 2 contacts to reset that. Well, that's what one of these relays does, and I forget the other one. So then down here, this is sort of the pneumatic stuff, and this is the interesting thing. This thing, we bring in, your air comes in, goes to a regulator. We have it set right now at 80 pounds, and so you've got 4 80-pound lines. One goes to this valve. That valve opens and closes that ball valve back there. So your outlet valve on and off. And then this one is extend, retract for your main water ram. But it's fed this pressure. And this is the thing that it takes a signal, an analog voltage in, and converts the line pressure to variable pressure. So this is a really cool thing. And you'll hear it going, and that's, it's like little up, little down, little up, little down, little full up, way down. So it's doing, it's regulating this whole pressure thing. So that's more or less it. It just,
So don't freak out when you hear it?
yeah, you have the 2 thermocouples. One of them's coming in through here, and another one's coming in through there. Thermocouple wires, those are your analog inputs for thermocouples. Here is your position sensor, and there's your pressure transducer. So there's 2 more analog inputs, 1, 2, 3, 4 analog inputs. And then these are your outputs, so like turn on the light, turn on the fans, turn on the cabinet light, open and close this valve, turn on these things. And so this is the schematic. And I'll show you that schematic briefly in this book here. Yeah, so this is your book. And your book has stuff in it. So I'm going to finish writing up how, this is the protocol that you said you wanted, so you can do that. It does a static test followed by a burst test. So it does one and then the other. And then, so then I'm going to redo this, but we're going to go with because we were messing with this today. But here are the parameters, and here's how it's going to work for static and burst. Then your schematic. So this is kind of what I just walked you through. Bring in your 120 volts, turns it into 24, and it runs it into these terminal blocks, and then your power on and off switch. This is your safety circuit. And so that your valves that you want safe can only get their power when this thing is operating correctly. E-stop and door sensor. This is the PLC. If you looked at that, it looked the same.
Absolutely.
So the wires are the same, the colors, locations. So that's what your PLC is doing. And then individual sensors, like this is what measures the position, and that's a really cool little sensor right back at the bottom of that water ram, the intensifier. There's that pressure transducer. I'm sorry, that's the one in the back for position. This Centronics is this thing right here. And that's this banner LED light. This is the flashing light. And then these are the rest of the valves, your fan circuit. Fan goes to a relay. So this is kind of a functional, why don't we have another one of those? I guess I have 2 more. But that's kind of a functional circuit, how it works. So if you're trying to figure out, well, how does it plumb and whatnot, it kind of shows you, you got your city water, goes into your inlet valve, then there's a check valve. And then when you're pressurizing it, I'm sort of saying that it turns red, high pressure. That's your high pressure circuit in red. And so It gives you your real pressure here, and it sends it into your test part. And because it's red and black, it's all at the same pressure. It's just that the black one is the return, the dump, it goes to ground. So when this valve is closed, it's all red, if you will, but just so that we have a difference so that we can understand this is the in and the out. But then that dumps into the bottom, and we were looking at that drain down here. So that's where that water goes when you're done using it, flushing. So it goes in through your part and then to the bottom of the tank into your drain. And then the Horner, these orange lines are the analogs. So you got temperature here and temperature here, 2 temperatures. And then you have your pressure coming in and your position coming in. So those are your 4 analog ins. And then this one is sending 1 analog out. And that's going to the Centronics regulator. That's telling it how to ramp that pressure up. And then these are your valves. This one is open and closing the ball valve. And those 2 go up and down with your air motor. So it's just sort of like a functional diagram, what's going on. And then the rest of this is all your different drawings for spare parts or what have you. Blah, blah, blah. And then all of your manuals. And so let's say the Centronics Plus, this thing's made in Germany, and they typically have, well, this one might not. A lot of these things have factory calibrations, which are also in here. But if for some reason you guys really want to play with this thing and make it do special things, you can connect a laptop to this. It requires free software and a cable, but you can actually change the PID loops in there. Okay, here we are. This is, okay, I thought I remembered this thing was factory calibrated so that when you gave it 10 volts, you were going to be at, what is it? How many bar? This is all. 0 to 10 volts is 7 bar, 10 volts. So that's what their factory, that's how they set it up. We actually just set our own up from that. But this is, it's showing you that it's linear. And then the rest of these things, this Balif, this is really a cool sensor. This is this is magic, and it's non-contact. It lasts virtually until the apocalypse.
Probably not EMP proof. Probably not.
It probably is. It's in a completely encased. It's in a steel.
Yeah, but I'm sure it's picking up magnetic flux, which you need copper wires for. Copper wires melt in EMPs.
Der Micropulse Vakuumer mit.
Sounds impressive, Carl.
It's like, what are you saying?
So I think that's basically it. Pressure transducer calibration. This is what they said the factory. So at 10 volts and 4 thousandths, that's 1,000 psi. So as a practical matter, we were taking this and calibrating that. It should have been the other way around. But Missouri.
Okay, got it.
And that one has got its own calibration too.
I'm sure that's in here.
It's either in there or I have
Oh
it
yeah,
in
it's
here.
probably in the book actually. Yeah, it's in there.
Oh, I have to find
This is
it.
for the gauge.
Ashcroft.
I think it said it was 0.25% for the service gauge.
What is this? Test gauge. Where is the,
Certification.
yeah, where's the
What happens when you don't make your own book?
kids?
You almost don't need that handle if you want to.
Yeah. I have to be honest, we were having a problem with this machine not working for us. I put 2 check belts into the creek test, and I ended up taking one of them off. I did like the machine work.
At least there's no sugar.
Ashcroft. There is a knob on this gauge. And there's instructions on how to use it. Right here to set this 0, but it's really tight. We haven't loosened it up. We haven't banged this thing. It has not seen any shock.
So you can rotate if needed.
We've never gone more than 1100.
Well, I think Corey said he went to like 1250 once.
1250.
It scared him.
So this should be as accurate as the day it was manufactured.
Okay, good.
These are just the couplers necessary to connect it to
Yep.
your quick disconnect system. So
Is
one other odd thing is that this water ram is full of water, and if it goes outside for a day,
We're in trouble.
that's not a good idea. So I was trying to figure out, and I
You
don't know
mean
how
on
to
our
drain.
side, in our environment, you mean?
Well,
Yeah.
if it's getting, if it's
Carl,
getting
what
shipped
would
in a
happen
panel
if you
truck
flush it
for a day,
with like RV
It would be.
antifreeze or
I was
something?
thinking about injecting some antifreeze into it,
Yeah,
and you guys.
and we'd have to flush it out down there.
And so the way I would recommend flushing it is not only opening up the two valves and just let it run, but then cycling the ram up and down.
Right,
And what that'll do is it'll fill up,
Purge it
push
out.
out, fill up,
Right.
and then pretty soon it'll be antifreeze free.
right.
The oil drain bleed hole on this isn't there. They never put one on, and so it just makes it a little more challenging to do maintenance on it.
I had a couple gallons at home. I should have brought them to you.
Now, one issue is that there's seals, that there's air seals and water seals on this thing. After a lot of use, they may wear,
Mhm.
which means something might start to creep and whatever, and these do get rebuilt.
Yep,
TRD through John Henry Foster it's a fully rebuildable system.
anything else, Tim? I think that's,
The only, the thing
that's
to
about as
discuss
comprehensive of information as I can capture on a video.
is getting the